This week we're going to set you up understanding how to look at and read something that we call a crosstab, this cross-tabulation. Literally we cross two variables and calculate some things about them, and that helps us understand the relationship between two variables. This week you're just going to get familiar with looking at it, identifying the parts of the table, and next week we're going to really dig into how to do some statistics. We have some really cool computations that we can do to quantify the relationship, to see if there's statistically significant stuff that's going on in that table. So first, I have a basic crosstab here, and we have two variables. We have sex, we have men and women, so two categories in that variable, and we have agreement with some policy. I don't know what policy this is. It's just kind of a generic policy. So we have agree and disagree. So what we have is in the column, we have our independent variable. And that's kind of a convention, and by convention I mean it's the way the book does it. So we'll do it that way just to avoid confusion. Really, you could flip this and put the independent in the rows, and some people do that. But in this class, let's keep independent in the columns just for simplicity. So here's your independent variable, sex, male and female. Here's your dependent variable, agree or disagree with a certain policy. So you have 15 people that agree with the policy and 3 people that disagree. So you have a total of 18 people. You also have 5 people that disagree and 22 that disagree here. So that gives you 27. We have 15 men here and 5 men here. That gives you 20. And we have 3 women here and 22 women here, which gives you 25. So you can see that we can get totals for all of these different categories and put them out in the margins, and that's exactly what these are. Especially next week, it's going to be important that you only see these middle 4 squares as the actual table, the data in the table that we analyze. Out here we call these margins, and we talk about marginal products next week. So that's stuff to help us understand the table, but it's not actually part of the table, part of the data we're analyzing. So here we have some totals. And fix that up a little bit. Here we have some totals, and they help us start to understand the table. So what you have to realize is to keep in mind which variable is which. And we have men and women as the independent variable. And generally, we percentage through the independent variable and read across the categories of the dependent variable. So if you can kind of commit that to memory, percentage through the independent, read through the dependent. Percentage through the independent, read through the dependent. That will help you, and if you don't do this, you're going to get very mixed up and confused. So try to keep that in mind and try to stay to that. So what we have 15 men and 3 women, and it looks like we have 5 times as many men as women that agree with this policy. And in fact, in terms of raw numbers, we do, but that doesn't necessarily mean that 5 times as many men as women agree with the policy, because we have a different number of men and women in our sample. And if we had 1,500 men in our sample and 300 women, then 15 men and 3 women would be proportionate to the totals of men and women. So we have to turn these things into percentages, or else we can't really speak about what's going on. So to do that, we just take this 15 and we divide by 20. That gives us the percentage of men that agree with this policy. So 15 men agree with the policy out of 20 total men. 75% agree. Now we don't actually need to go beyond that with this cell where we see disagree. We know the answer. We know that 25% are going to disagree with this policy because we have 100% of men when we have the total. So this cell is not free to vary once we know the information in this cell compared to the total. So that's not free to vary, and next week especially you're going to need to keep that in mind, that only certain cells in this table are free to vary, and once we know what they are, the rest is determined. We can figure it out. In fact, we could also say that if we know 15 men and there are 18 total people, we know the other 3 are women, as long as we know there's only one other category in the table, because 18 minus 15 is 3. So really there's only one cell, and it could be any cell in this table. this, 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 this. If you have the totals, you can put in any cell and figure the rest out. So if I just had 22 here, I know this is 5 because 27 minus 22 is 5. And I know this is going to be 3 because 25 minus 22 is 3. So with one single cell, we could fill out the rest of this table. It's kind of like a cool little Sudoku puzzle or something like that. So we call that degrees of freedom. How many cells are free to vary? And in the case of this table, only one cell can vary. Once we have one cell filled out, we can fill the rest out as long as we have the totals. That's degrees of freedom. And we'll come back to that later. But as you can see, we have 75% of men here. So this has to be 25 to give us 100. And we know that 3 women out of 25 agree with the policy. So that's 12%. You just divide 3 by 25 and you get 12%. So this has to be 88 because 1 minus 0.12 is 0.88. So 88% of women disagree. And now we're in business because now we know that 75, and here's again where you read through the categories of the dependent variable, read through the rows. So 75% of men agree with the policy compared to only 12% of women who agree with the policy. So now we know that there are quite a few more men as a percentage that agree with this policy compared to women. And really the degree is just the flip side of that. It's just saying that more women disagree with the policy than men. We already knew that because we know that more men agree with the policy than women, so it's just two sides of the same coin. So you're all set up, and you can say something about the relationship between sex and agreement with the policy. Men are much more likely than women to agree with the policy. And that's it. You now can start to talk about the relationship between these variables, at least for this week. Next week, like I say, we'll quantify that and put some numbers to that through some calculations. But now let me make a point, because without fail, this tends to happen, okay? And sort of an aside before I move on. What happens if I add 25 plus 20 down here? That's all of the men plus all of the women, and it gives me 45. So is this the right total also for this? And it turns out that it is. If I add 27 plus 18, again, it's 45. That's because all of the men plus all of the women gives you everybody in the study. All of the agree plus all of the disagree also gives you everybody in the study. So those have to be the same number. And this is a checkpoint, just like we saw a checkpoint when we did standard deviation, where you should get 0. Here you should get the same number, adding the total through the columns and the total through the rows. Now, that having been said, let's turn this around a little bit deliberately and do this the other way. Let's percentage through the rows to see what information that gives us. So here 15 out of 18 people agree with the policy, and 3 people out of 18 agree, talking about women. Now 5 out of 27 disagree here, that's men. 22 out of 27 disagree here, and that's the women. So now what happens if I compare 83 to 17? In this case, it still looks kind of similar, and you get a similar result. But in some tables, it's really going to mess you up quite a bit. And the reason is because this is 75% of men agree with the policy compared to just 12% of women who agree with the policy. But what is this? Take a minute and think and put into words what you think that is. If we compare those two numbers, what are we comparing? Of everybody that agrees with the policy, 83% are men and 17% are women. Now why can that mess us up? Because if we have very different numbers down here, and in this case we don't happen to, but if we had 500 men instead, this would mean that if we kept this at 5, and this is 495, and this is going to now be 3 plus 495. Now 99% compared to less than 1%. It looks different than it really is, and that's just because we had really disproportionate number of men and women. It has nothing to do with whether or not more men agree than women. And in fact, by that token, we could reverse it and make this 250 and this like 10. So that leaves us 5 here. And this will be 250 minus 22. Okay. So now it looks like tons more women agree than disagree. That's not what this column means. It means of all those who agree, 98% were women, but that's because so many of the people in the study in general were women. Here you have 250 out of 260 people. 96% of people in the study in general are women. So it doesn't make sense to interpret it that way. X this out, delete it from your brain, from the screen. It's going to lead you down the wrong path, and it's going to make you sound silly if you don't happen to have pretty even numbers in your categories of the independent variable. So this gives you a quick introduction. Hopefully it's helpful as we get into this. And next week we'll come into this a little bit more and show how we can quantify this. And it's really cool stuff. And it's a lot of fun to start off and talk about statistical significant differences between these categories. And it's a segue into some other stuff we'll do with regression analysis. And you're just well on your way to becoming a budding statistician and being able to use these things at work and to interpret statistics all around you when you see them pop up on the news, on the internet. You can really impress your friends and your coworkers, and I'm excited to learn more about this with you.